All righty, friends. So we're going to finish off our last little bit in chapter 6, and we've got a couple more things left to do this year in AP Calculus AB, and we're just going to get more practice with separation of variables. Okay, so at this little bit, our separation of variables is going to be just a little bit more. So find the particular, a little bit more than what we've done before. It's going to be a little bit more just to it, as far as separating the variables and going from there. So find the particular solution. So we're just going to solve some more advanced kind of differential equations. Dx dy, oops, dy dx equals 2x plus 1 over y given y of 1 equals 5. All right, friends, go and pause the video. Let's see what you guys can do with that, and then we'll come back and take a look at it. All right, so when I solved it, I cross multiply. Whoop. So y equals, oh, sorry about that. Got my dy there. Y dy equals 2x minus 1 dx. So again, today's just kind of a drill and kill day, but we're just going to be doing separation of variables with a little bit more advanced type of integrals. So we go ahead and we integrate both sides. So 1/2 y squared equals x squared minus x plus c. Now, I'll be honest, I don't want that 1/2 in front of it, so I'm going to multiply both sides by 2. So if I multiply this side by 2, and I multiply this side by 2, I end up with y squared equals 2x squared see here, there we are, 2x squared minus 2x plus c. Now, real quick, when I multiply this constant by 2, this is not the same constant. So because of that, this is where I need to go back. And again, we talked about this a little bit last class. Make that a subscript because this constant is not the same as this constant. Okay? So now I'm going to go through and I'm going to say, all right, well, if I want to continue to get y by itself. If I can get y by itself, I have to. I get y equals plus or minus 2x squared minus 2x plus 5. So the question that comes up then, plus c, I'm sorry. The question that comes up is, which one of these do I want to use? Is it the positive square root or the negative square root? And it comes down to this. What is the value of my term? So College Board is going to ask that you write a little bit here. So since y of 1 equals 5, which is greater than 0, then y of 1 is greater than 0. So that gives me permission, since y of 1 has to be greater than 0, that means I'm using the positive square root here. So this is going to be the positive square root. I'm not dealing with the negative, I'm going to be dealing with the positive square root. So we have to give ourselves permission to know which square root we're going to be dealing with. Okay, so from there, we go ahead now and we plug in our values. I know that y is 5. And I'm going to plug in 1 in for my x's. Oh, that was weird. I took my finger off the thing. There we go. All right, so we end up with 5 equals 2 minus 2 plus c. So 5 equals the square root of c. So 25 equals c. So that means my actual equation then would be y equals the positive square root of 2x squared minus 2x plus 25. All right, let's have you guys try one of these yourselves here. Let's see what we can come up with here. Let's give you guys, x minus 2 and 2y. And let's go ahead and give you guys y of 0 equals -4. All right, go ahead and pause the video and see what you can come up with. It's always fun to use Magic Eraser. All right, let's see how you guys did. So if I separate my variables, I get 2y dy equals x minus 2 dx. So we separate our variables. Now we integrate both sides. And I end up with y squared equals 1/2 x squared minus 2x plus c. Got to get y by itself. So y equals the plus or minus of the square root of 1/2 x squared minus 2x plus c. And then we have to write a little bit so we know which square root to use. So since y of 0 equals -4, then y of 0 is less than 0. So that means I'm going to use the negative square root. I'm not dealing with a positive square root. On this one, I'm dealing with a negative square root. So we're going to go and plug our values in here now. So I have 4 for y. Equals the negative. Oh, that should have been -4 on that side. Sorry about that. There we go. -1/2 times 0 squared minus 2 times 0 plus c. So -4 equals a negative square root of c. So 4 is the square root of c. And then we square both sides. 16 equals c. So our actual equation we're dealing with here then is y equals the negative square root of 1/2 x squared minus 2x plus 16. All right, let's give you guys a little bit more here to kind of play with here and just kind of consider. 2x plus, oops, not what I wanted. There we are. 2x plus 3 3y squared and y of 1 equals 2. All right, friends, why don't you pause the video on that one? Give it a try. All right, so we're going to separate our variables here now. So we have 3y squared dy equals 2x plus 3 dx. And we take the square root, integrate both sides, not quite the same thing. Y cubed equals x squared plus 3x. And to get rid of the cube, we're going to do the cube root. So y. The nice thing is about cube roots is we don't have to worry about plus or minus. So there is no plus or minus. So there's no write-up for this one. And we can go right on in. And my -2 really didn't turn out well, did it? Did not notice that before. -2 did not turn out well at all. So we're like, -2? I didn't know it was -2. It's supposed to be. There we go. All right, so you got a -2 in for y equals the cube root of 1 squared plus 3 times 1 plus c. So we cube root both sides, we end up with a -8 equals 4 plus c, and I end up with -12 equals c. So y equals the cube root of x squared plus 3x minus 12. All right, friends, we are about halfway through here. Halfway through. Let's go through and see if I can't give you some other ones here to kind of play with a little bit. How about we try this? Y minus 1 x, and let's let y of 1 be equal to 4. All right, go ahead and pause the video, see what you guys come up with. All right, so we notice on this one, when I get the y minus 1, it's in the denominator down here. And my x is in the denominator on the other side. So when I get my x's and y's all separated, when I cross multiplied it, my y's were in x's were both in denominators, which tells me I'm dealing with natural logs. So natural log of the absolute value of y minus 1 equals the natural log of the absolute value of x. So I'm going to clean this up here and get rid of the natural log on the left-hand side. So that makes this e times the natural log x plus c. And friends, I know that this side on the right is positive. So if this whole thing is positive, then y minus 1 has to be positive. So since e to the natural log of absolute value of x plus c has to be positive, and since y of 1 equals 4, then y minus 1 is also going to be a positive value. So I can go ahead and drop the absolute value and just make it a y minus 1. So we do a little write-up again just to try to clean things up for ourselves. And I'm going to actually change that to, no, not yet. I won't. So y minus 1 equals, and we did this last class, so we're kind of used to this by now. And notice I got two things going on here. E to the c, well, that's going to be just a constant number. Well, this constant number is different than all the rest of the c's, so I have to go back and subscript all these, which is a little bit of a pain, but there's worse things in the world. And then on the second one, notice I have e raised to the natural log. Well, in natural log, they're inverses of each other, so that means that that is just going to cancel out. I'm left with just the absolute value of x. For some reason, I put equals there. Why did that? There we are. So that means y is equal to c times the natural, or the absolute value of x plus 1. So we know what our values are that we're plugging in. We'll go ahead and plug them in real quick. So 4 equals c times the absolute value of 1 plus 1. So we get 3 equals c. So that means our final equation we're dealing with here is y equals 3 times the absolute value of x plus 1. All right. Let's give you another one here to just kind of play around with a little bit here. Like I said, we only got two left here. We're only doing 6 today, just to kind of get some ideas of different things. So I decided to cancel that one out there. 2xy plus 8x and y of 1 equals -3. All right, friends, go and pause the video and take a gander at that one. All right, so if I'm looking at that right side, I can factor it out. So dy dx, I can factor out a 2x there, it looks like, to get y plus 4. So that y plus 4, I can move to the other side. So 1 over y plus 4 dy equals 2x dx. We're going to integrate both sides. I keep wanting to put y out there, or use a white color. White doesn't usually work well on white screens. All right, and again, when we integrate both sides, we get the natural log of y plus 4 equals x squared plus c. And lo and behold, friends, again, we are going to do our swoop and get rid of the natural log there. So this becomes e to the x squared plus c. And by now we're getting used to the write-up. So since e to the x squared plus c is greater than 0, and y plus 4 is greater than 0 when y of 1 equals 3. So we're dealing with positive values here. Then I can go ahead and use just the positive absolute value here. So y plus 4 equals e to the x squared plus c. So e to the c, e to the x squared. We're multiplying those together. And again, e to the c will be just c. So y plus 4 equals c times e to the x squared. Which means those c's aren't the same. So I'm going to go back, like we talked about before, and I'm going to subscript all these c's because they were not the same c. So that means that y equals c times e to the x squared minus 4. Now, friends, on this one, we're going to go ahead and plug in our -3 and our 1 for the y and the x, and we're going to solve this for c. I'm going to run out of room here if I'm not careful, so I'll just move it over here to the right. C e to the minus 4. And friends, we end up with 1 equals c times e, or 1 over e equals c. So our final answer then, when I plug it all in here, I get y equals 1 over e times e to the x squared minus 4. And if you really wanted to get really cute, you could actually put it together and do y e. All right. All right, friends, one final problem. We're going to go ahead and call it a day here. Because I don't know about you, but it is Sunday morning. I got to get off to church here. So we end up with, let's try this. 3x squared minus 7 all over 5y to the 4th plus 3 for y of 0 equals 4. All right, friends, give that one a try. Let's see what you guys can do. Final one. Here we go. So we have 5y to the 4th plus 3. We get all our variables separated here. dy equals 3x squared minus 7 dx. Integrate, integrate, And friends, I end up with y to the 5th plus 3y equals x cubed minus 7x plus c. Now, look at the left-hand side. Notice the white is on the left-hand side. There is no way I can get y by itself. So since I can't get y by itself, that's okay. We call that can't isolate y. Then we just all right, so we can't get it by itself, so we're just going to go ahead and move on. If we can't get it by itself, no harm, no foul, no sense making a big deal about it. We just move on. So we're going to substitute our 4 in for all the y's. See? There we go. And we plug all the numbers in here. We get 4 for y, 0 for x, and we end up with 1,024 plus 12 equals 0 minus 0 plus c. So 1,036 equals c. So our final answer then is y to the 5th plus 3y equals x cubed minus 7x plus 1,036. All right, friends. We'll see you in class tomorrow. We'll talk a little bit more about this. Take care.